Good afternoon. My name is Chuck Gunn with the Fluke Corporation, and I'm here today to talk to you about the Fluke-810 Vibration Tester. The 810 is quite often used to analyze common equipment such as motors, fans or blowers, belts and chain drives, gearboxes, pumps, compressors, and spindles. And what it's able to do is detect the root cause of these mechanical failures that occur. These failures are associated with bearing problems, misalignment, unbalance, and looseness. For today's demonstration, we're going to develop a new test, and we'll call it Fluke number 1. So as you can see, I'm defining the test name. As I said, I'm calling it Fluke number 1. I'm going to move the cursor down till I get to the number 1 spot. I'm going to hit done. We'll go to the next step, which is part of the setup. Now we select the type of the motor, which is AC. As we proceed with the setup, we're going to select the motor type, which for the test box is an AC motor. We'll hit enter. We're going to tell it whether or not it's attached to a variable frequency drive, yes or no. In this case, the answer is yes. Enter. We're actually going to define the RPM. So I'm going to start up the system. The next step is we captured the RPM with the laser tachometer. Then we want to move over and enter the horsepower. In this case, this is a 1/4 horse motor. The next thing we have to do is define how the motor is mounted. In this case, the motor is horizontal. Tell it what kind of bearings it has. If it doesn't have journal bearings, all bearings then would be classified as roller bearings. Now we have to tell it whether the motor is detached from the drivetrain. In this case, the answer is no. Is the motor close coupled? The answer is yes, because it's simulating being tied to a fan. Now we have to tell it what it's tied to, and as I said, it's simulating being tied to a fan. The last step is optional. That defines whether or not you want to tell it how many blades. So in this case, if I was going to say that a fan has, say, 3 blades, I could do a manual entry off of a keyboard and say that it's a 3-bladed fan. Now we're done with the initial setup. The unit will go and save this, and it will retain the setup in its memory. From there, we're going to go ahead and pick the orientation of the sensors. We're going to put some new sensor orientations in. Notice that you see a picture of the motor and the fan up at the top left of the screen. I'm going to go ahead and put the sensor on location number 1, which is the free end of the motor. I'm going to start the motor up. Notice that the system is asking us if the sensor is on location number 1. I'm going to hit enter. Now we have 3 choices. We can do a top or bottom, we can do an end, or we can do looking down from the top, which is this one right here. We're going to tell the system that we're on the looking down from the very top, and we're going to hit enter. Now you have an orientation. Which way does the cable go? You want to keep the cable vertical to the shaft. I'm going to use this setup. Enter. Now the system is ready to measure. It's checking the sensor cable. It's going out and measuring. After this, it's going to ask me to move to the next location. Now I'm going to tell it that we're going to go to the second location. I'm going to move the sensor. I'm using the magnetic mount today. I'm going to make sure it's firm in its placement. I'm going to tell the system that we're on location number 2. It's asking me, is it on location 2? I'm going to tell it yes by entering. I'm going to make sure that I use the same placement as the last time, as the last test. The system's going to check the cable to make sure it's still good, and it's going to go out and do a test. It's measuring. The last step is the easiest of all. It's the diagnosis. With the push of a button, the system is going to go out and diagnose any problems that are discovered. Now you're going to notice that this says extreme imbalance. It's saying it also has motor imbalance. This is pre-set up so that the system is unbalanced. If you can see this, on the shaft of the motor, we have a weight that is offset, which will throw the whole system out of balance. We do this on purpose so that we can show a failure on this test setup. Now, not only do we have this information, which, as you can see here, shows the most extreme failure up at the top, which is imbalance. Then it tells us where, and it says motor imbalance. If you need additional information, you can go into the details section. The details section shows you the axis, the locations that we looked at. It gives us some information and orders and tells us what the range was. I'm Chuck Gunn with Fluke Corporation. Thank you very much for seeing this demonstration of the 810 Vibration Tester.